Let's calculate the sensible cooling load due to ventilation. A space receives 5,000 cubic feet per minute of outdoor air at 95 degrees Fahrenheit. The return air leaves at 75 degrees Fahrenheit. All air is at sea level, and the density of air is approximately 0.075 pounds per cubic foot, and the specific heat at constant pressure is 0.24 BTU per pound degree Fahrenheit. What is the sensible cooling load attributable to ventilation? Here are the choices. A. 54,000 BTU per hour. B. 86,400 BTU per hour. C. 108,000 BTU per hour. Or D. 160,000 BTU per hour. Which one is correct? Let's visualize the ventilation process. We have outdoor air coming in at 95 degrees and return air leaving at 75 degrees, flowing at 5,000 cubic feet per minute. We know the density of air at sea level, ρ, is 0.075 pounds per cubic foot, and the specific heat at constant pressure, C sub P, is 0.24 BTU per pound degree Fahrenheit. We use the sensible heat equation for ventilation. Q sub S equals 1.08 times cubic feet per minute times delta T. The constant 1.08 comes from 60 times ρ times Cp. Now, let's plug in our numbers. Q sub S equals 1.08 times 5,000 cubic feet per minute times the temperature difference, 95 minus 75. First compute the temperature difference. 95 minus 75 equals 20 degrees. Therefore, Q sub S equals 1.08 times 5,000 times 20. 1.08 times 5,000 equals 5,400. Then 5,400 times 20 equals 108,000. So the sensible cooling load attributable to ventilation is 108,000 BTU per hour. Reference: NCEES Handbook Section 6 Psychrometrics. Sensible heat equation Q sub S equals 1.08 times CF m times delta T.